I remember friends in like 6.
Funny thing, I didn't even play Roblox in year 4. Or year 5, or year 6. I started playing it in 7.
Started 3.
Yeah, I started playing it in year 7. I've been playing it ever since. It's literally nothing to do with it.
I don't really understand the concept of it.
Isn't blocks for its one piece?
Yep.
So how does it work?
I don't know. Slap people, kill them, they get XP level, they get stronger. So you can kill stronger people, that works, and you get even stronger.
Alright guys, join the live stream.
Kill more people. I can't,
You try
I
again.
don't know if I can find it.
Try again. This is your second chance to redeem yourself.
I'll try my best.
Oh, Justin's on. Justin's here. Can you hear me?
Yeah, I can hear you.
Alright, stop. I'm streaming. So what we did in the morning was we proved that there's infinitely, you can, if you have an alpha is irrational, you can, I think Justin, this might be reviewed for you. So there's infinitely many fractions that approximate alpha within 1 on q squared. Okay. And then we did this example. This example here. I'll just paste it in. Can I paste it in the chat here? Oh, I guess I can. And okay, so now what we're gonna do is gonna use this. So this is for, so you're given alpha, right? So it's irrational. Okay, and then we want to find, and then we want to show there exists infinitely many PQ. This, okay? And if there's one, there's infinitely many, okay? Alright, now we want to use that to show that there exists infinitely many solutions to Pell's equations. So we've actually shown ways to find the Pell's equations, and we want to continue with that afterwards, but I want to show you this is because this is really cool and it continues the theme, okay? So if you have this equation, I can show you there's infinitely many solutions, okay? All right. And so this is like n is not a square, okay? So if you look at this,
Recording in progress.
so can you see that? So essentially, if you do Pell's equations, the solutions have to come from rational approximations. Okay, we proved this before. So it'd be nice to see if you can actually prove that you can actually solve the equation with approximations, and then continued fractions give you a way to figure out how to get those rational approximations. Okay. So you start with a rational approximation of root n. Yeah. Oh, wait, this is for you.
Yeah.
Give me your phone. Thanks. Let's sit on this couch. Sit on this seat. Yeah. Give me the phone. You can get another zipper, yes. You can put that in the bin.
So.
But you gotta listen while you're walking over there. So we start with the rational approximation of root n, okay? Then we times both sides by q.
Yeah.
And we get this expression q root n minus p, yeah? Is less than 1 on q. Okay, and then we realize both sides. We times both sides by q root n. We times both sides by p plus q root n, yeah? Yeah? Remember this?
Yep.
You times both sides by p plus q root n. You get p squared minus n q squared. So that's the left-hand side to Pell's equation, yeah? Is less than p plus q root n over q. You get that? Okay. And then once you cancel out the q, okay, you get p over q plus root n, yeah? Makes sense? But remember, p over q is close to root n, yeah?
Yeah.
So this is roughly 2 root n here, okay? But the point is this is bounded, okay? So it's bounded by 2 root n plus 1. That makes sense? Okay, so if it's bounded by 2 root n plus 1, okay, so if it's bounded by q root n, 2 root n by plus 1, and there's infinitely many of them, they're all bounded by the same bound, yeah? There's only finitely many integers. So, since p squared minus nq squared, yeah, is integer, and its values are bounded, there are only finitely many possible values, yeah? Since we know there are infinitely many fractions p over q, right? This means that infinitely many of these correspond to some one integer, yeah? Integer, let's call it k or m or something, yeah? M, yeah?
Yeah.
Let's say m, okay? That is infinitely many solutions to p squared minus nq squared equals m, yeah? Okay? There's infinitely many solutions to p squared minus nq squared equals m. Okay? So what can you do okay, is you can try to divide that out. Does that make sense? So, so you can take, and try to take, we now try to turn these into solutions to Pell's equation that is equal to 1 by dividing out the m, okay? So what does this mean? So it might look something like this, okay? So you take so P1, Q1, and P2, Q2 are two pairs of these M solutions. Then we consider, so this is kind of tricky. So you have like P1 plus the square root of n. Shush. He can actually learn this. If you can't, don't stop him, okay? So Q1 Q2 So try to consider this thing and try to turn it into a solution. You understand? So the idea is because this one equals m and this one equals m, when you cancel them out, it should equal 1, right? So the problem is, are you allowed to cancel out? Okay. So what does this actually equal to? So this equals to this equals to, so if you times the bottom, if you times the top and bottom by the conjugate of the bottom, yeah, you get sort of P2 squared, right? And the top becomes I'll send Justin the link as well.
Someone said hi. What's up? Someone said hi.
Okay, so what's that like wrench they have?
Huh?
What's like the wrench that the person who said hi has?
Let me see. Oh, that's just my kids.
Oh, but why does he have a wrench? Is he like a moderator?
I don't know. The editor? Okay, what was I saying? So you get this, right? So remember, kind of like, so we're trying to show, like, when you write P1 plus root n Q1, right?
Yeah.
We're kind of thinking of P1 and Q1 as the solutions, yeah? But this kind of way of writing it keeps track of it, because root n, like, if you write something as integer plus root n times integer, that expression is unique. Okay, so it keeps track of both these integers separately. Alright. Okay, so but we have to write in that form. So the top is not quite in that form, but if you expand it, it will be in that form, right? It'll be, oh, that should be P2, Q2. Yeah. So let me just change that. So it should be P2. Should be P2 Q2. Okay. And then when you times that out, so like P2 plus Q2 root n, yeah, times P1 plus Q1 root n, yeah, is equal to P1 P2 plus n Q1 Q2, yeah. That makes sense. And then plus root n, it'll be P2 Q1 plus, oh, that should be a minus. That should be a minus, yeah. That's a plus, that's a minus, yeah. That's a minus, so it should be, this should be a minus, okay. And then P2 minus P2 Q1, and then it's, sorry, it's plus P2 Q1 and minus Q2 P1 root n, yeah? You understand?
Yeah.
So this should be a minus here.
Yeah.
Okay. Okay, so these kind of things good for you guys to point out, yeah? Because it kind of proves your listening and understanding. Whereas if, and also like if you never find it, I could just scam you, right? It's like, yeah, that's true. And then, but then we never get to the end, so I can't actually get, like I scam myself too, I can't get there. Okay, so P2 minus Q2 there. Okay, and that's equal to, remember P2 squared minus Q2 squared is just m, right? Yeah. And on the top we just wrote down here is P1 P2 minus n Q1 Q2 plus, I'm going to do this, root n, and it's P2 Q1 minus Q2 P1. Okay. So it's like that, yeah?
Yeah.
Okay, so here's the thing, okay? Maybe this is the thing you can tell me. I'll give you a few moments to think about it. So I'll give you at least 6 minutes, but you can probably have a little bit more. But so what's the problem with this at the moment, you know?
We're not divisible. We're not an integer, but
Yeah. So Liam's got it. We don't know if this is an integer. We need integer plus like these have to be integers to be solution, yeah? So essentially we need to know whether these are divisible by m or not.
Yeah.
Okay? So the question is, can you show that they're divisible by m or not? Yeah? I'll give you at least 5 minutes. Let me know if you have your habits.
We go to the PDF.
Okay.
Okay, the PDF.
什么？给你一点。
要拿整个啊，我再切一个给你。
But need some paper down. Alon, paper. Thank you. Thank you. Thanks. Can I see the pencil?
Alon, are you in the live stream?
Yeah.
Thank you, Alon.
What?
Wait, he was on the live stream.
Should be.
Later.
Definitely showing.
What are you looking at?
Alright. Join now.
Oh. Oh. There's nothing to see. Wait, no, I'm in the live stream. Oh, do you want it back? Alon, go hand it to him.
Yeah.
Alon, there's nothing to see. Go hand it to it.
Justin, do you have it? Type something else to make it more clear. Shit. Okay, so that should focus it more. Does this problem make sense to you? Fine. What if I sent you the link? Let's quickly send you the link. So laggy.
So was this something in general, so?
Really?
Yeah.
That's not the link. Oh yeah, they put the link on the live stream. Alright, did you get it?
It's unavailable.
Unavailable. Why?
So unavailable for me. I just didn't sign it.
Most people put this on suspicious Russian YouTube.
Hmm. Okay. Alright, so can you see if P1 equals P2 and Q1 equals Q2, right?
It's done.
The numerator is just M and you're done, right? Yeah? And the same on this side, yeah? Yeah? Then you just get PQ minus PQ, yeah? But you can't hope to be that lucky, can you, right? Okay?
Yeah.
But you don't need it to be equal, yeah? Okay? Like, you don't, like if you want that to happen, okay, you don't actually need that to be equal for that to happen, right? You actually just need it. You just need it to be equal mod m, right?
Yep.
That makes sense. So you want to show it's divisible by m. You just need to be equal mod m, yeah.
There's an infinite number of solutions. There has to be an infinite number of one thing mod n.
Yeah. There's infinite number of PQs, and there's only finite many mod m's, right? So there has to be one mod m, for which infinitely many of them.
Yep.
Yeah.
At least one mod n.
Did you read the other side?
We cannot hope. We probably should not hope that
Normal
these
Union Jack. What?
are
Plan.
divisible by m, and they are probably not. Okay, but notice if P1 equals P2 and Q1 equals Q2, then
It's an absolute investment. Just the desalination plants are incredibly expensive. Idiot.
Actually, we only need P1 equals P2 mod m and Q1
Trying to
What?
Are you trying to do it?
to apply this argument here. However, since there are only finitely many pairs modulo m, but infinitely many pairs PQ, there must be some pair modulo m for which infinitely many of these PQ have that modulus. Does that make sense? Okay. To check that these are indeed solutions,
We know there's solutions though.
yeah.
Depend either. Weird. Never met someone. Stop being annoying. You have no friends.
I think it's something like
Alright, stop, you both
Name
annoying
one
me.
friend.
We can take advantage
Name one friend who
Oh.
counts as a person.
conjugating by
Sure.
anything you name for a friend.
What?
to minus square root n. Yeah? That is okay. So you choose x, so x squared minus ny squared equals. This is where you do this fraction thing. You do this fraction, and you times it by the same fraction with minus, because this is equal to x plus square root n, x minus y square root n.
We wrote x plus square root n in one bracket.
Thank you. If only you could point it out before I fixed it.
What's this,
Yes.
We wrote x plus square root n times. Once it loads, we'll see the mistake. Where did you write it? You wrote it's equal to x square root n times. Everything just went wrong there, didn't it?
Not everything.
Yeah. There you go. See, that's what I was pointing out. I told you would make a mistake.
Yeah, once I get this book out, if you find mistakes like this, I'll probably pay like $1 per mistake.
Or was it at 50 cents before?
Yeah, 50 cents.
Inflation has struck.
Inflation.
$5 now.
We'll see.
Minimum wage is still the same.
Mine will be paid sub-minimum wage.
Okay, so the whole point is you got x squared minus ny squared, right?
Mm.
To check if it's a solution, you just need to times it by its conjugate, yeah?
Yep.
Okay, but then you can times it by its conjugate. You don't have to do it at the end, which is probably difficult, right? You can do it at the start, which is actually easy, yeah? If you do it at the start, you just get m over m, see?
Yeah, which equals 1. You're short. What?
Alright, stop attacking the Goliath over here.
If you know, if I wanted to, I could pick you up and just drop you off the balcony. No issue. It would be a minimal effort activity.
Close for the catch you, I guess. And second, you have to survive the nuclear weapons.
Given the tiny environment we're in right now, catching is not an issue. And even if you have nuclear weapons, their deployment will take longer than it will take to drop you off a balcony. And mutually
Oh,
assured
just be
destruction,
quiet.
right,
Yes, and should be assured stuff.
does not work when the other person doesn't mind being destroyed.
Don't talk authoritatively here, okay?
Neither
You all have no authority.
It's like you sucks get this killed.
I don't get your point.
Okay, so, and Justin, we did this, I think we did this on Friday. So we did this on Friday that if you have one solution, you can get all the solutions by powering the n, okay? So if you want the video, I can send you the video for that. Which takes this conjugating thing to its maximum potential. But this is pretty cool, right? So we proved that there's infinitely many solutions to Pell's equation. Okay. So we've also proved, so how much time is that? So we've also proved that every solution to Pell's equation has to be given by one of these good approximations, okay? So they're all within 1 on 2y squared of root n.
Yeah.
Okay? Alright. And we also proved previously that anything that's within 1 on 2y squared of root n, okay, comes from a continued fraction.
Ooh.
Okay?
Nice job. Wait, that does it.
Yeah.
Oh.
But what we haven't proved, okay, so we also proved that in a continued fraction for root n, every time you have a period, that fraction gives you plus or minus 1 as for the Pell's equation, okay?
Yeah.
Okay. But we haven't proved that the other ones don't give you plus or minus 1, yeah?
What do you mean?
Like, we don't know if the other ones are solutions or not either, okay? And so we don't actually know that those ones are all of the solutions, okay? So it turns out they're all of the solutions as well, okay? And so the thing I really want to prove, or maybe go through the proof of, is that if you have a continued fraction and it's a solution to Pell's equation, okay, it has to occur at the periods. It can't occur in the other places. Okay? Does that make sense? So let me highlight this a bit more. So if you have square root n, okay, the continued fraction for square root n, it looks like this. It starts off with the integer part, right? And then it does a whole bunch of stuff, like it goes a2, a3, a4, and then it goes back down to 3, 2, 1, yeah? And then when it goes back down, it goes to 2 times the original one, and then this part just keeps repeating and repeating and repeating, okay? So when I say the length of the period, I'm really talking about sort of this length here, or what's the same thing as this length here, yeah? So it's how long it takes before it repeats.
Yeah.
Okay? So the claim is, if you take the fraction, if you cut the fraction off at one of those periods, the fraction you get, the numerator and the denominator are solutions to Pell's equation, but it could be minus 1, okay? But if it's even, if the total number that you took, the length is even, then it's plus 1. It's a solution to Pell's equation, okay? Does that make sense? Does it make sense? Let's see if Justin. Does this make sense to Justin? Okay, yes. Good.
Recording stopped. Recording in progress.
Okay, so what we want to do is we want to show basically this statement here. So I got this statement. If PQ is the smallest positive solution of the equation. Wait, that's not what we want. Here we go. If the rth convergent of root D gives a solution to Pell's equation with plus or minus 1, yeah, then it must be a multiple of the period. Okay? Okay, so I guess we could either read the proof or try to come up with it ourselves. So the standard practice, I think, as told to me by Professor George Eliot, is to try to prove it yourself when you can. It's like you kind of read the proof just kind of for a reference. But yeah, because sometimes like there's some skill in actually setting it up, because if you kind of state it properly, it might not seem as mysterious as it sounds. Okay, so maybe I'll cover it up. So rth convergent. You have like, we have root n, right? And it equals like a1, a2, a3. It goes all the way up and then back down a3, a2, and then 2a1, right? So this length here, you might call it, they call it r, k, yeah? We can call it l. Well, we call it l. Let's call it l. So you have like r equals, I don't know, like ql plus, see the letter r is not great either. Let's say n. N equals ql plus r. Okay.
Yeah.
So remember, we did also root 2 and root 3, yeah? This is true for root 2 and root 3. So root 2 and root 3 is like 1, 2 repeater. And every even one, so the period length is 1, right? So that means every even even is a solution, every odd is a solution to minus 1. Yeah? Root 3, I think it was 1, was it 1, 1, 2 repeater, like that.
Yeah.
So the period length 2, yeah? And so every even one is a solution to Pell's equation, but every odd one is a solution to like minus 2 or something. And there's actually no solutions to minus 1, okay? So that agrees with the examples, a few of them. Okay, I'll give you one paragraph here. Okay, so xk is like the tail part. Xk equals the tail. Yeah. So here's probably a very key claim here. It's enough to show xr plus 2 equals x2. So why is it enough to show that xr plus 2 equals x2? Okay, they're obviously using a different r to us. So we're using n. Okay. Some of the stuff they're saying doesn't make a whole lot of sense.
Yeah.
But it's enough to show that xn plus 2 equals x2 seems to make sense. What's that saying? So what's xn plus 2? So it's like alpha m plus 2, or am plus 2, am plus 3. Keep going, right? And then x2 is a2, a3.
What they're saying about it being enough is correct.
Oh yeah, why is that?
Because if xn...
Oh, if it's a multiple of a period, it should just be equal.
Yeah.
Is that true though? What if it like it repeats? Like what if it's like 1, 2, 3, 4, 5, 6, 7, right? And that's just like, I guess that can't wait. So what if it's like 1, 2, 1, 2? I guess it can't always be equal. Yeah, I guess it's something specific to root n, because root n doesn't have any, like, it has like one exceptional part. It doesn't have enough to fake that they're the same. Okay, so they're saying if we show that xn plus 2 equals x2, then we're done, yeah? Okay, so what's this stuff about if p, q are the smallest positive integers such that blah equals -1 plus -1, then the previous theorem just says it comes from continued fractions, yeah? Then p over q is the rth conversion for some capital R. And we would have x capital R plus 2 equals x2. And also k equals capital R. Wait, does that make sense? What's the smallest solution? So I guess it's not. It's not. It's like also the smallest R for which it's the rth conversion, right?
Yeah.
Very sus. I feel like we need to lower our standards a little bit here. What's going on? We replace plus or minus 1 with -1 to the R in the equation. Since odd convergence are less than root d while even convergence are greater, we have root d equals that, which rearranges to that. This is quite a mystery, actually.
You sure this is a legit website? This bit sucks.
It has crypto in it to me.
I mean, it doesn't have to be legit. We should be able to figure out the proof anyway.
It was like reading a bad proof can almost be harder than figuring out the proof yourself.
Yeah, I mean, I guess that's kind of the point, right? Because at the start, I mean, sometimes it can be more valuable to try to figure out how this works than having someone present it to you very clean. Oh yeah, and Justin, if you can let us know what you have as well. Yeah, so I don't get, so if P and Q are the smallest positive integers, yeah, then from the previous theorem, P on Q is some convergent, yeah. And we would have x r, capital R plus 2 equals x2. I don't get that. And also the period is capital R. I don't get that either, okay? Otherwise, we would have a smaller solution. Since x k plus 2 equals x2. I mean, if k equals R, then sure.
Can you just throw the... Wait, xk is equal to... How does xk work again?
Oh, so x is meant to be the tail. So if you have like root n, right?
Yeah.
That equals to like a1, right?
Yeah.
And then it equals to like
Bunch of A's.
x2, like that.
Yeah.
Right? Or it equals to like a1, a2, all the way up to a r plus 1, right?
Yeah.
And then x r plus 2. No?
Oh, X is the next value in the thing.
Hmm?
X is the next value in the sequence.
X is the next value in the sequence.
Yeah.
X represents the rest of the sequence.
Yeah.
Yeah.
Oh, I think I know what they're saying.
Oh, okay.
Because they're not saying R. They're saying R is just because K is the period, right?
Yeah.
So if X R plus 2 equals X2, then R is the period, right?
Well, it's a multiple of the period.
Yeah.
Yeah.
So that makes sense.
But why is x r plus 2 equal x2?
That's what the proof is trying to show.
The proof is trying to show that small r plus 2 is equal to x2.
Yeah.
It's trying to claim the capital R plus 2 equals x2 is somehow obvious.
What's the previous theorem?
The previous theorem. No, it just says they're convergence. There's nothing. So there's nothing here. So we know that if it's a solution to p squared minus dq squared plus or minus 1, then it comes from one of the continued fractions.
Yeah.
But it says for some r, I guess we should take a minimal r, right?
Yeah, they're saying it's the minimum R. You
Yeah.
assume it's the minimum R.
Okay, because it's the smallest positive, right?
Yeah.
Because if you take a bigger r, it'll give you a bigger solution.
Yeah.
Okay, you take the smallest r, and we also know like the converse. Okay, we know that if you start with the period, okay, it'll be true. Yeah.
Yeah.
Maybe that's the key to the proof.
What do we know about the period again? Can you say that again? We just said.
We know that the period gives you solutions. Yeah.
Ah.
Okay. So if we take the smallest solution, it should give you exactly the period, right?
Yeah. That's what they're saying.
Yeah. Okay. So I think I kind of get how to do this, but I'm not right. So if you take the smallest r, could it be bigger than the period? It couldn't be, right? It has to be less than the period.
Yeah.
Right? Could it be? And then we're going to show it can't be less than the period, right?
Yeah.
So the period equals some multiple of r, right? Yeah, I think this is a kind of a standard argument. Like if the period is a like if it's you could write it as a quotient remainder form, right?
Yeah.
If the period is like this plus a remainder and s is not 0, yeah.
Yeah.
Then you look at the continued fraction. Let's see. You do it at s. You do it at s. Does it actually work every R? I guess it's not a simple matter of multiplying them or something. But usually the argument is something like if it works for L, it works for R, then it should work for S. Yeah? Then S would be less than minimal. So yeah.
I think that's what they're arguing though.
No, that's not what they're arguing. They're just saying the period equals R straight away.
Yeah, but why?
But they're not really arguing. Actually, one thing about reading math, sometimes you can get the next bit without worrying about the previous bit. The next bit's kind of interesting. So,
Yep.
so assume this is true, okay? Because I don't think I have time to explain it to you two. But basically, when you get continued fractions, there's a way to get the numerator and the denominators in terms of the A's. The recurrence in terms of the A's. Okay? But, okay, oh yeah, so Justin might cut out because of the laptop. Alright, thanks for letting me know. Okay, so yeah, so usually this expression is for like PR plus 2 on QR plus 2, okay?
Yeah.
But that would only go up to AR plus 2, yeah? But what you have is now you have the same A's at the start,
Oh yeah.
but instead of AR plus 2, you have the tail here.
Oh yeah, that's the thing. Yeah.
Okay, and that's why you have what?
Isn't it just an approximation of root D though, not equal to root D?
No, it's equal because this thing is not rational.
Oh.
Yeah, but you can take the R wherever you want, and this expression will be true.
Yeah.
Okay, so here we're taking it at the R plus first spot. Yeah. Okay, so you can assume this pretty safely. So if you assume this rearrangement is actually pretty obvious. Yeah, you just times the denominator across.
Yeah.
Okay. So if you times the denominator across, you have, what do you get? So I guess what they're trying to do is they're trying to collect the XR plus 1, right? So you get PR, which is this,
Oh,
yeah,
I see.
minus QR root D, yeah? Okay, and then you put the other stuff on the other side. So this is QR minus 1 root D, and you minus PR minus 1, yeah? So this is correct, yes? Okay. So now what do you do? Now you times both sides by P to the PR plus root D QR, right?
Yep.
So that'll get rid of, that'll make this a minus 1 to the R here, okay? And then you times this thing here, and you times this by PR plus root D QR. Okay, and then what you get is you get minus PR minus 1 PR, that's this, yeah? Plus QR minus 1 D, which is this, yeah? Okay. There seem to be missing a few terms here. Supposedly the other stuff should just give you, and then you get PR, so PR QR minus 1 root D, yeah, and then minus QR PR minus 1 root D. Okay, and then we do know that this expression here is equal to minus 1 to the R, yeah? Okay. So you actually get this plus minus 1 to the R root D, yeah?
Yeah.
Okay. Okay, and then when you times both sides by minus 1 to the R, yeah?
Yeah.
And then you get x to the R plus 1 equals root D, and it's, I guess it's plus,
Yeah.
plus some integer. Plus
Yeah,
some
you're
integer.
right. Right.
Yeah, so I'm a little bit worried if it's minus some integer. Could it be minus some positive integer? I guess we know XR is positive, yeah?
Yeah.
So even if it minus, I'm just kind of worried that, like, so this is plus some integer, yeah?
Yeah.
What if it was minus A1 though? Would that make a difference?
Thank you.
Okay, so the whole point of this, right, is that if you have XR plus 1 is root D plus an integer, right? Like the first step of when you do the continued fraction, yeah? Like if you have some number like root 2, right? The first step of the continued fraction is to take the integer part out and then flip the rest. You know what I mean?
Yeah.
So like, if you add another integer to root 2, like if you did it like 3 plus root 2, right?
It doesn't make a difference. Wait, no.
It pluses 3 to that, but it doesn't make a difference to the
It
rest.
doesn't make a difference whether it minus. It's the same thing. Because you still take out an integer part and you get left with x2. It's equivalent. It doesn't matter.
Alright.
Because you still have the same fractional.
Yeah. I think it does matter if it's 0, but I think luckily you can't get 0.
Yeah.
We know in advance it's not 0.
Yeah.
And we know it's positive. So it's gonna be some. The point is that when you get to xr plus 2, it's gonna be the same as the root d.
Oh, that doesn't.
x2, yeah.
Yeah.
So what's all that stuff about at the start?
You need the stuff at the start. But they don't use stuff at the start again, do they?
I feel like none of this is used, right?
Yeah, exactly.
It's kind of weird. It's kind of good in a sense because it doesn't offend our sense of elegance.
I've realized something about a lot of maths group. There's no massive one really difficult to find idea. This isn't like some insane idea anyway. It's just a lot of decent ideas that are just carried out with a bunch of like,
Yeah.
oh, so much.
So in some sense, if you learn this, you're kind of leveraging the time it took at least for all these people to come up with this, right? Like this, like how can you ever like get ahead of thousands of years of maths? Like, yeah, sure, genetically maybe you're superior, but I don't know. You kind of leverage a lot of this stuff. So then, like the skill becomes sort of to recognize what your problem is, how it's related to this problem,
Oh, yeah.
instead of trying to solve it again every time as well, right?
Yeah.
Leverage. So what? So that thing was just to put us off.
That makes a lot of sense. Aside from that nonsensical statement at the start, this proof isn't too bad.
Yeah. So does it suffice to show xr plus 2 is equal to x2?
Yeah.
Alright, maybe to digest this, we need to write this up ourselves without reading this. So all this stuff was just kind of like, what is that even? Is that literally a red herring?
Yep.
What's a herring look like?
A fish.
I don't know if I drew a fish.
Let me draw.
That looks like what does that look like? I don't know why you're thinking that.
You're thinking.
No, you're thinking that.
I didn't ever say I was thinking that. Michael, you must be thinking that then.
Socks.
And you're a weird foot fetish guy.
What?
Stop.
Michael, this kid's been obsessing over my socks all day.
What? Socks.
Okay, so we now prove that if we have a solution to Pell's equation with
No, wait. Oh yeah, we got it.
then it must be P and Qn for the period divided. Yeah, so we have already shown that it must be Pn Qn for some n. We now show that the period L divides n.
Alarm. You like feet?
We first show that
You don't understand what socks are?
alpha 2 equals alpha n plus 2. Where alpha I where square root n See, the saying "where" after you use it is like standard bad writing practice, by the way. Okay. Standard badness. You're meant to always declare it first.
Are you okay? Alright. Call from Slava, not me.
Okay. We first show that alpha 2 equals alpha m plus 2. Alright, do you guys remember what the kind of idea was?
Yeah.
So okay, so square root n equals. So see if you can figure this out as I'm doing it. So it's the fraction where
Px plus.
yeah, so we need to use the alpha n plus 2 somehow, right?
Yeah.
And it's plus p something, yeah? And then we'll have alpha m plus 2. Yeah, I've also considered proving that relation as well, because we need that relation for complex numbers at some point. So, but that's the kind of thing where I'd like to do earlier in the day when the juniors are here.
But how close are you to finishing this book?
How close?
Yeah.
I mean, I have the skeleton all written. It's just there's so many little details.
What percentage of the way through did you yourself?
I mean, in terms of, you mean hours? So I might see, like, I might not, like, for example, I might just release it with mistakes, because it's better to release it, people can use it, than to have, like, every typo removed and take 2 years longer, you know what I mean?
Yeah.
But, like, yeah, I might, like, if people find mistakes, I'll put it on a website with the mistakes listed, and I'll reward them, like, $1 for every mistake or something. So if you buy one of the earlier copies, you could probably get it for free by just finding all the mistakes.
True. But every mistake I find will take off labor time instead.
But you're reading it anyway.
True. Oh my god, how have I become? You're all so annoying. I'm not like that ridiculously rich.
Right, I think you gotta stop annoying him.
Thank you.
Unless, what do you like?
Your dad works for me, Matt.
Yeah, but your dad's like higher up by a lot.
Wait, what just happened?
What?
What just happened here? I just wrote it in the wrong place. Yeah, it's here, right?
Yeah.
So if it's alpha n plus 2, it must be the previous one then, right?
Yeah.
This must be n plus 1, and this must be n. And
Yeah.
proof. Oh, it's because there's no closed dollar signs.
Sorry, you need to put in your closed dollar signs.
I did.
Yeah, that is correct.
So root n equals that, right?
But you sure had alpha n plus 2 in it?
It had to, right?
No, because I didn't show alpha n plus 2 was equal.
Oh, alpha n plus 1.
Yeah.
I have to do Pn minus 1.
Right. Because what they showed, sir.
Yeah, it was like the previous
alpha n plus 1. Because they showed it was some integer difference from root n.
Oh, actually, now I'm curious. What happens if it's alpha n plus 2 then?
Fill off with 4L.
Wait, I'm curious now. What happens if it's alpha n plus 2? So you do alpha n plus 2, yeah? Alpha n plus 2 times qn plus 1 root n, right? Minus pn plus 1, yeah? Equals pn minus qn root n, yeah? Okay, so the issue here is the left-hand side isn't as simple.
Yeah.
But you do it to the right-hand side, yeah? But what's the point of doing it to the right-hand side? Okay, so divide this, yeah? You get minus pn minus qn plus 1 root n, yeah? Okay. So this is supposed to equal the second thing. It's not quite obvious what to do, is it?
What time does it escalate?
Oh. That means you're not following. So for you,
You should just turn the clock on your computer, Michael.
it is on. It just doesn't come up sometimes when I'm in the
Because
other
you
mode.
turned it off, it comes.
4:30. I mean, you can go as soon as this proof finishes, really.
Rather What happened to your head? What? What made you so annoying?
What do you mean?
It's actually very strange that alpha n plus 2 is like a quotient of these things. So what is that? It's like it's plus or minus 1 to the n, let's say, yeah? Over minus pn plus 1 minus qn plus 1 root n times pn plus qn root n, yeah? I think we get something very so you get a pn plus 1 qn minus qn plus 1 pn, right? So that's like a minus, so pn plus 1 minus qn plus 1 n, and then the other one is plus minus 1 to the n plus 1 root n. Okay. So you get something similar. You get like, so you make that minus n, you get 1 over. You get 1 over minus 1 to the n plus 1 pn. I kind of feel like this should work because, I mean, why shouldn't this work? This is more natural as well. It's this plus root n, yeah?
Holy.
Yeah, I think that shows the same thing. Because you know the continued fraction looks like this, okay?
Yeah.
Dot 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 plus 1 on alpha m plus 2.
Yeah.
Understand? Okay. I mean, look at what look at this thing here. It's the same idea, yeah. So you have some integer, okay. What is this? Wait, so did I actually get alpha? I got alpha m plus 2 equals this, yeah?
Yeah.
So then the bit that's 1 on alpha m plus 2, yeah? So the bit that's like a m plus 1, yeah? Plus alpha m plus 2 is actually, it looks like this, yeah? Yeah? Yeah, so whatever happens here, right? It should take out all the integer part of the root n, right?
Yeah.
And then the very next step should be whatever the next step is would have been for root n, right? Does that make sense? So it kind of messes with am plus 1 a bit, but...
So basically what you did is instead of showing alpha r plus 2 equals alpha 2, you showed alpha r plus 3 equals alpha 3.
No, it's still alpha plus 2 because this
yeah,
is all in the m plus 1 part, yeah?
Oh yeah, that makes sense.
And then the next part, which supposedly is here, yeah? So the crazy thing is this thing here must be like kind of like a1, right? It has to be like minus a1 or something.
Yeah.
Yeah. I think that's a more natural proof, don't you think? I don't know. Because you have m plus 2, so you keep that in the equation, right? Okay, so we rearrange this. Are you regretting you stayed alone? You did learn something.
I'm sure he's capable of learning, so.
He is, but the one who is asleep cannot be. Okay, so rearrange this. So rearrange this to get.
Somehow you didn't end up. You belong in C9. What in the world is C10? It's just a normal room. I belong in the normal room. You belong in C9.
Okay, so alpha m plus 2 equals.
Yes, I run the school. You belong in Mr. Ferguson's office getting in more trouble.
What is wrong with you? Be quiet.
So you use the wrong brackets.
It's so delayed. I've already changed that.
Just inform yourself.
Okay, so is this right? Pn minus Qn square root n. And the bottom is minus Pm plus 1. Minus. And that equals, so you go to the power of n minus 1 to the power of n. So the problem is it actually minus 1 to the power of n? See, it could actually be to the n plus 1, right? But did you guys raise that objection? Yeah, I could probably include more steps, huh?
Have you written anything for the senior book?
What do you mean?
So, how do you plan on writing the senior book?
What do you mean?
Because this book you had exercise that you could. The junior book you could basically write whenever you wanted. Class, we're giving them exercises. The senior book is like Sunday only. It's still kind of even questionable for Sunday.
Yeah, I mean, we'll get to it.
Because do you think George and Victor next year will be as strong as like Alex or Daniel or Leo or
They could be.
Joshua?
They could be. Don't count them out.
I'm just saying. I know they could be.
Justin's in year 10 too, by the
Oh
way.
yeah, Justin will be.
Okay, so yeah, it's really okay. So what do we got here? So here we got minus 1 to the n equals that. Okay, and then this equals that. All right. Okay, so what's the final line gonna be? See, Alan, even if you don't get some of these, you can still do the calculation parts, you know? But then, like, when you come back to it, you'll have already, like, understood, like, 50% of it. Okay, so this minus 1 to the n plus 1 is actually p m plus 1 minus dn qm plus 1. Did I have it the wrong way around? What the? Why is this backwards? I have the later stage earlier.
Oh my gosh, sir. It's Milan. A micro man. Dragon Striker Summer Sorted Number.
What?
If Summer Sorted Number at the end of your name, I don't remember it. What is it? Short. Then never rebut to short. Because it's a fact. You are short.
Please. I am also short. Collateral damage.
Compared to Alan's, you're tall though.
But
And given Alan's current growth pattern,
no, given your current growth pattern, I feel like whatever shortness it applied to him will apply to me very soon.
yeah, but will Alan reach your height though?
You think you need to insult people more specifically? Like it's gotta be really personal, you know what I'm saying? Like only he'll get offended.
You just don't want to be the collateral damage. Alright. Excessively skinny.
That's enough.
You wouldn't be in the collateral damage for that.
Yeah, but just saying, okay? It's not really that insulting even.
Yeah, I know. But you kind of were in the collateral damage, and that was kind of fun. Very subtly in the collateral.
Okay, so did you get this? So
Suffering from mental retardation.
You just offended yourself.
How?
okay, so if you look at this, right? So the whole point is since the continued fraction ends as this, right? It ends as an plus 1 plus 1 on alpha n plus 2, right?
Mm.
Yeah.
Yeah.
So for 1 on alpha plus 2 to be like less than an integer, right? This literally forces this thing to be root n minus a1, yeah?
Yeah.
It just has to be that.
Mm.
And if it's not,
Then your proof is incorrect. Oh no, then you made a mistake.
oh, wait, what is it saying? So, yeah, like if it's any bigger than that, right? Then it would come out with the an plus 2, 1, right? Yeah, like that value for it to go into the next continued fraction thing has to be between 1 and 0, right?
Yeah.
Yeah.
How to install alarm?
Okay.
You want me to rip off my... What the hell? That's a bit suspicious.
Since the end of the tail
Oh, you... Alright.
continued
Micro
fraction
The micro...
looks like. So let's put some dots there, and then we have
You know
like
what I was gonna
a
You
m
are
plus
the micro
1
the micro.
plus 1 on alpha m plus 2. Okay.
This is not micro man, it's the micro.
Are you trying to be witty right now? It's kind of like pathetic, really.
I'm not trying to be with you, it's a terrible insult.
Your socks.
These are normal socks.
Your kind of insults are just like, I'm better than you, but I can't be bothered really making up an insult.
Yeah, exactly. It's a lot.
Those are not normal socks.
What are they then, if not normal socks?
They're suspicious.
Wait, am I missing a bracket here?
You're a suspicious man. How did you not make it to the Falcon class?
Stop.
Oh, no, I'm sorry, sir. I was going to tailor my insults a bit more. So you wouldn't be caught in the crossfire.
I just kind of try to collaborate with. He's like a resource for you. Do you understand? Like if you two, you go to the same school. If you just work together, you could both be great. You understand? Both be greater. Relative to each other, you'd probably be less great. Okay, but relative to everyone else, you'll be much greater.
True. Right, stop being incredibly annoying. And then we can get to it. Getting great.
Stop being so annoying.
Okay, I can finally erase all this stuff now. Hopefully this will be clean for you to see.
But how do we know that's true though?
What's true? I don't know what's true.
Did you just redefine it to be AM plus 1?
What?
What?
No, the continued fraction goes am plus 1, then am plus 2, right?
Yeah. And you added AM plus 1, right? So now it's AM plus 1?
Like the continued fraction, right?
Yeah.
It has it's like a1, a2,
Yeah.
all the way up to am plus 1 like that, right?
Yeah.
And then it's plus 1 on alpha m plus 2, yeah?
Yeah.
But alpha m plus 2 is 1 over that, right?
Yeah.
So then that becomes am plus 1 plus that.
Yeah.
Yeah?
So
And because am plus 1 is the continued fraction thing, right?
yeah.
This bit can't have any integer part.
Yeah.
It has to be like between 0 and 1, right?
Yeah.
So that forces this part to actually be just root n minus a1.
So you basically went back, did your own, and then got back to their proof's idea.
I mean, you can't avoid the idea,
Yeah.
right? That's the point. But like this is more. I feel like this is more direct.
Well, I feel like there are. This is more direct, I agree, but I think it sacrifices a bit of simplicity.
Simplicity is identical.
No, like in expression. Like their proof was, I think, simpler to express.
Simpler
Their
to
method of
express.
reaching it. Yeah.
It's. Do you know what the difference is? It's literally like
Yeah.
they did alpha plus n plus 1,
True.
and they got this in the numerator.
It would have taken longer to write your thing.
What?
The thing just looks longer.
I actually wrote it out. That's the difference.
True.
Like,
Well, that's good.
This
Alarm.
means that
You should come to Problem Solving Club. I decided to do a read through of PST. You see, Problem Solving Club, not very successful. That's what needs to become more successful. Yeah.
Oh yeah, the one time I like tried to go so in the second one was like
Anyway, so my grand idea to make Problem Solving Club more interesting, to just do like a read through of problem solving tactics.
are you sure that will work?
minus A1.
Good option.
Let's see.
I don't think an 8 read through is a good idea for beginners.
Okay, but remember what's also that's also like A2 plus something, right? Like remember, like we have like A1 plus 1 on, right? And then this is square root n minus A1, right? And this is equal to alpha 2, you know? What? Wait, I feel like something went wrong here. 1 on 1 on alpha n plus 2 is square root n. Wait, what just happened here? Oh, okay. It's not like that. It's 1 over 1 over, yeah? Like it's 1 over 1 over that, yeah? Yeah? So this is alpha 2, yeah? You understand?
Yeah.
So if alpha n plus 2 equals alpha 2, must n be a multiple?
Yeah. Because it's kind of like orders mod a prime. Because continued fraction is periodic, right? So the alphas are periodic as well.
Mm-hmm.
And if it wasn't, so alpha 2 goes to alpha 3, etc., back to alpha n. And it repeats like that.
What if the period was like, it's like 2, so it's like 2, 3, 4, 5, like, you know what I'm saying? Like, and then it's like a random 2, and then it's like 7, 5, and then it starts going back down. 7, 2,
Yeah, but each alpha you get would be unique, right?
5, 4, 3, 2.
Each alpha you get would be unique. Because alpha
It
determines...
takes the whole lot, right?
Yeah. If an alpha repeats, then the sequence starts repeating.
Oh, okay. So if
each alpha is unique.
the alpha takes, like, if that was that, it wouldn't work, right?
Yeah, it would be different.
You need the 2, 3, 2.
Yeah.
Okay. Yeah, so that actually completes a lot of proofs here. I guess, Alon, you can go if you want. But we're probably going to keep going for a little while. You can stay also if you want. But, so what does that prove? It proves that, the continued, see, because it would have been kind of a bit lame having continued fractions solve Pell's equation, but then have to use that algebra stuff to process it more. You know what I mean?
Yeah.
So actually, the continued fractions solve it completely. They're all the solutions. Okay.
Yeah.
Yeah, and there's not always a solution when it's -1. Okay, so even when n equals 3, capital N equals 3,
Yeah.
there's no solution to the -1 case.
There's always solution to it. So,
Yes. What is it?
what? Yeah.
Oh, my phone's gonna die. I need to charge it.
Are you saying?
Really? He's just not bothered to leave.
Slava's saying?
Slava's. Oh.
Mate.
I think they're both. It's not like they want to stay, they just aren't bothered to leave.
I'll give you a very short toilet break, okay?
Is there any more food?
Yeah.
You are food.
Oh, okay, Justin has to go. Okay. Alright, have a good one, Justin. Oh, it's actually 5.
Yeah.
You're gonna go.
Alright, see you, Justin. Actually, maybe it is a good time to go.
Some probably gonna go.
Yeah, maybe it is a good time to go. Because if they go, I can try to see if your homework makes sense.
Alright.
Or if you wanted to stay, you can just watch and see if his homework makes sense.
My dad's picking me up 30 minutes.
Oh, okay.
Recording stopped.
Alright, I'm just going to the toilet and then we'll see if his homework makes sense, yeah?
My homework has never not made sense.
Has never not made sense.
Because if like that, like,
I have to say, Maths Olympiad, it's different from school maths.
No,
Because you have another degree of rigor. You know you're not making like. I always know when I'm when I've solved a problem. Like, but you know when you've completely solved it. And I can't.
Yeah, you do get a feel for it.
Yeah. Especially once you write it up. Because when you write it up, you'll quickly notice if you missed a case or something.
Mm.
Or, standard's too difficult, no one likes.
Is that lazy?
Yeah. You know what you should do? You should be my like. Yeah, you should get me like a wheelchair and wheel me around.
Should I?
Why not? You're probably like a sub. Oh, good boy.
Nice seat, William. And if I take it?
Yes, I mind.
Okay.
I will correct this issue. There we go.
Okay.
Really?
Good point. Never mind.
So, do you have any lollies? Yeah. Can we have some lollies? It would help us, you know, for the last hour of the lesson. Lollies are always a useful commodity, amenity.
I see your point.
Wait, what's your like rank or something on Clash Royale?
What do you mean, like?
I don't know. What's your arena? What? Like, aren't there like master champion things like that?
Oh yeah, I'm champion wait, let me check. Wait, no, I don't want that. Just once I win. So I never lose.
This kid never loses. What? Guess what arena? What like league thing? What cheer is in?
Coffee. Oh, what is it?
Ultimate champion.
Oh, okay. That's
Yeah.
wow. How much do we play? I looked at the
Why don't you ask Test XO1 for Wuchi's how he plays Clash Royale.
He's an ultimate count. It's a brand new.
He's also on the Australian IMO team.
Mhm.
And he's in my year. Maybe he's just naturally gifted.
You see that? Season.
How much do you grind?
I could find a lot if I did cheap.
Show me what thing you're in. So what arena are you in?
I can't remember what it's called, but 7.5. Wait, 7.5.
What's the maximum?
9.
Did you distress the baby?
Maybe.
Unfortunately,
Oh yeah, you know Otis has exams. Michael.
Yeah. Alright, let's have a look at your thing. Okay, so if you guys remember,
They weren't there.
no, I showed something just then.
Oh yeah, true.
Recording in progress.
So remember, all the solutions to Pell's equation can be gotten from the continued fraction, and from that thing where you do like the smaller solution, you power it up, right? So the homework was just to prove that for root 2. Okay, which Liam claims to have done.
I think write-ups have gone a bit better.
What's with this? Okay, it's here. So continued fraction for root 2 can be expressed as
Is that correct?
yeah. So like k is something something, yeah?
Yeah.
It's not true for like k equals 2, 1 or 0. Huh?
Yeah.
Okay, so basically you have these sequences, yeah? And they're defined like this. If p and q are the smallest values of the continued fraction for... What? Why?
Because that's what you did in the video.
The smallest?
Yeah, because you took 1 plus root 2.
Yeah. Why
As your
didn't you
base.
why didn't you do 1 plus root 2?
Yeah.
Why not just 1 plus root 2?
It's the same thing, but yeah.
No, it's not.
Wait, it's not?
Because you don't know what these are now.
True.
So here you should define P1 Q1 to be 1 1, right?
Yeah.
Yes. And P2 Q2 to be 3 2. Yeah.
French hat.
To define P1 equals Q1 equals 1 and P2 equals 3 and Q2 equals 2, right? So for k greater than or equal to 2, yeah. So you don't even actually need to know that they're from a continued fraction. You just know that see, because you don't need to say if, right? That's making it confused. What's the prime thing? Yeah, so now you define. So all this is not relevant. Yeah. So now define P PK prime QK prime.
But use P prime K, just because that's the notation I use in every other thing. You probably don't want to change that.
Just wait. So you can delete this. Yeah. That's a 1. Yeah. That's a K. Yes.
Yeah.
Equals.
Put the prime on the other side.
It won't make a difference.
Because that's how I defined it in every other thing.
What do you mean?
Just leaving it.
Oh, then you did everything wrong because you put the subscript on the prime. You understand? That's what you did.
Yeah, that's what
Can you tell the difference though?
You can't, it's identical. It's identical.
What was that? Yeah.
Huh. Maybe it just thought it was too ridiculous to continue. Now suppose all values of both sequences up to. See, this is where like you don't need to say too much. You can say now suppose PK prime equals PK and QK prime equals QK for all, less than K, right?
Yeah.
We obtain PK plus 1 equals that. Okay. Equals 3 PK. Where'd you get this from?
Where's your above relation?
This relation?
No.
Both of these relations?
No.
Are you sure you want to say no?
Whoa! Well, I made a typo, but this is meant to be PK minus 1. But I used these. No. These, yeah, I used these. That's what you said.
Yeah, okay. Great, thanks.
Sorry.
You must love being corrected because
What?
you correct other people so much. Usually, if you don't like something, you don't do it to other people. You understand?
True.
Oh, so you just changed the two PKs
Yeah.
into yeah. So you're kind of saying PK plus 1 equals 2 PK prime plus PK minus 1.
Yeah.
And
He's not gonna go for it.
3. Shouldn't it be 3Q?
No, because the PK.
Oh, the PK adds up.
Yeah.
Shouldn't it be 2 PK plus 2Q?
No, it's
What?
there's 2 times PK, so it's 2 PK minus.
Oh, there's
1.
4 of those.
Yeah.
Oh,
This is like identical to what you did in your video stuff.
okay. So you're attributing this to me. Your begin proof. What's end of?
It can be attributed to you.
I'll attribute it to you, okay?
Oh, thank you, sir. Alarm, what are you ranking in the world at Clash Royale?
Probably like 15, 20,000.
Our clan's actually top 15 in Australia.
What?
You're getting brilliant runs and blocks around like 15,000.
Alright, so here,
Or only like 30.
PK plus 1 prime equals that. I shouldn't have written that. That's just the normal recurrence, right?
Yeah.
I don't know.
I kind of want to. PK plus 1 prime. Wait, you did something annoying. PK plus 1 prime is PK prime. Plus, why'd you write that backwards just to annoy me?
Oh, no, I did that so it matched what was at the beginning.
Beginning?
Like the other 3 PK thing.
This one?
Yeah. And why'd you add the primes? You don't need the primes, they're equivalent. Lower terms.
Yeah, but with the prime here, I think to do this more naturally.
True. And then you get, what? And then you just repeat the same thing. So you get 2QK minus 1 plus 2PK minus 1 plus PK minus 1 plus 2QK minus 1.
Wait, PK is... Oh, it has the 2QK.
Yeah,
And this has 2QK, so it's 4QK, yeah?
exactly.
And then 2... Yeah, so that's the same.
Exactly. So I did the homework, so do you believe me now?
Yeah.
Really the best Olympic player in the world. It's such like top like on like 500 players. Alex one time to like
Actually, do you need them all to be equal, or do you only need them to be equal? Well, you only need like the k minus 2 things to be equal, right? Wait, so what do you need to be equal? You need You need the k to be equal, right?
Yeah.
And the k minus 1.
Yeah.
You know?
Yeah, but we have that.
Yeah, but you didn't say it.
What?
Yeah, like you'd legitimately lose a mark in HSC for this, and you wouldn't be able to complain, right?
But I wrote all values of both sequences up to those ones that are equal.
Yeah, but there could only be one value, right? You don't know what k is. So here, I suppose. So now nodes P1 prime equals Q1 prime equals 1 and P2 prime equals 3 and Q2 prime equals 2 and suppose it's easy. Just suppose this equals PK. Yeah. So you didn't take care of these things, right? If you don't know how to take care of these things when that's all that there is to take care of, then when you have multiple things to take care of, you're gonna crash and burn, okay? That's just a fact. Right, you see? Look, so now you have an induction because you actually you needed two things to go back twos, right?
True. Oh, yeah.
And you don't need to assume all of them, just need the previous two, yeah? That's more efficient, you see? Okay, I'm missing an equal sign here. Wait, what's going on here?
Well, I'm proving that the Q's are also equal.
Oh, wait. Oh, okay. It kind of just skipped. What is this? Where did this come from? QK plus 1 prime. Oh, you did this again down here. Super annoying. You swapped the order. Like an annoying person. Especially here when it looks like the other relation. Like here. It kind of looked like the other relation as well. So PK plus QK. So in the thing there was there's 3 and 2, is that right? Yeah.
Yep.
Yeah. Yeah, so here is just hence. Yeah. There's no need for artificial line breaks, you know. Yeah, you don't really need to write a complete proof. I don't understand why the end document is not begun document or something.
Totally predicted to accidentally. Predicting accuracy.
Is it good, sir? Now, after your corrections.
Did you read it?
Yes.
It looks very different now. So what did you prove, you know?
We prove that logically.
They're all the solutions, right?
Yeah.
There's 2 ways of getting one.
Yeah.
Okay, very good. What did we
Recording
do for the last
stopped.
half hour?
What's the time now?
It's 5:26.
We don't just choose a random problem and try solve it.
Yeah, I'm up for that.
Not for prep, I don't know. I don't like the prep problems as much.
Bonker.
Maybe a prep.
No, it will just
Maybe a
like
prep
that.
combi.
It will just like 2,000.
Maybe a prep C problem.
Well, what about like finish the A8? You think we finish that?
I don't know. In half an hour.
Okay.
What about like a
Yeah,
prep
unless like
C6?
he dies with ban.
Prep
Hey, no,
C6.
wait, blood chocolate. That's still good.
Oh, what? Where are all the viewers? Is that just a glitch? Are you guys not in anymore?
He's too busy playing Clash Royale.
He's so bad, he like completely choked.
I feel like if you're gonna be here, you might as least should be in the stream.
Okay, he's on your dad coming in like 3 minutes.
Right. But we should look at C6. Do a C6.
C6. Why
Yes.
6?
I don't know. Because 7 or 8, I'm not confident enough in my combi abilities that I can solve them in half an hour. Or C6 is somewhat doable.
Seems somewhat doable.
C6, like, just, it should be doable in half an hour.
Okay, let's have a look.
Because I know I'm...
Do you understand? Rascals, this is making to be making it over listening.
What is the...
Michael looking through all these...
Yeah, Michael, you should get a bot that just pings everyone on the stream.
I got a message from Yasser.
Oh, what did Yasser say?
At least it no.
Yeah, it should be low. There you go.
Should we look at C6?
Yeah. Alright, see you guys.
Uh, what is that now? 1
C6. So C6, you think that'll be an inter server?
It'll be an Intel, yeah.
C6. Oh, well, it looks like, I don't know, it looks like graph theory. I haven't even read it.
No, it's not right. Ooh. Maybe. I don't know. What do I do with... Wait, which class? I go to Tuesday and Sunday. Wait, what should I do for in terms of Monday next term? Because I'm like way too strong. Unless I join in like kind of Lucas role like it was in Tuesday.
Well,
Because
so there's still, so, I mean, to be fair, like, back in the day, Hai Bing went Sunday, Monday, Tuesday. But he would do, like, Monday and Tuesday online. But he would still participate very seriously, you know what I mean? It was like, because
Well,
even like, for example, if I do Monday, right, and I'm teaching you bow tie theorem, which you obviously know, right?
Yeah.
You can still prove it with complex batch,
True.
right? So there's still, like, it's the level of rigor is up to you, right?
Yeah.
And if you didn't spot the issues before, you should, you know, like,
Yeah.
if you still don't notice the diagram dependencies now that you
Yeah.
didn't notice the first time, like, then maybe you should be in Monday, you know what I mean? Like,
Yeah.
yeah, like, it's kind of like, well, I'm in Monday class too, right?
True.
Does that make sense?
But you're the teacher.
Yeah, but I'm like trying to learn as well, you know, like,
Yeah.
it's not like, you know what I mean? Like, I feel like the lesson can't be completely uninteresting to
Yeah.
me, you know, like, it has to have some,
Yeah, that makes sense.
yeah, so that's why, like, every time we kind of give a different proof or, like,
Mm.
you know what I mean?
Yeah.
Kind of keep it a bit interesting. Obviously, the good ones are the ones you can repeat, the really
Yeah.
great proofs, like the bow tie one. I clicked paste, but it didn't. Or is it on the bottom? Scrolled. Whoa, there's a lot of highs. Okay,
Oh,
my
it's
bad.
Lucas.
Delete the message. Okay, so at midday,
Yep.
N ladybirds. I don't know, that sounds kind of sus. At midday, N ladybirds are placed as on some of the. What the?
Yeah.
Are you still wanting to do C6?
Alright, we can do C7.
I was gonna. Fine.
At midday, no ladybirds occupy the same vertex. Yep.
No two ladybirds occupy the same vertex.
Meeting the vertex.
Vertices. Ah, okay. So it's like a square grid, but you're doing in the intersections of the lines. Immediately, all of the ladybirds began crawling at 1 unit per second along the grid lines. Each time a ladybird reaches a vertex on the grid, it changes direction of motion to a new direction that is perpendicular to the old direction. So it's like
Yeah.
left or right. What is the smallest value of n such that regardless of the initial positions and chosen paths, we may be sure that two of them will eventually meet at a vertex?
Well, we know that n is greater than 2020 times 2022.
Oh, why?
This problem's somewhat like, you know the Taiwan babies problem?
Yeah.
Somewhat like that kind of movement.
Okay, but this time, like, it's not clockwise or anti-clockwise. It could be either way.
Yeah.
What is the smallest value of n such that regardless of the initial position of the chosen path, the lady... Yeah, I guess you could assume it's all clockwise for like... to get you some kind of... Maybe show that eventually two of them will meet at a vertex.
I feel like trying 6 would be interesting. Wait, no. You can wait.
What is the smallest value? Regardless
It's the exact same problem as the Taiwan babies.
Well, I guess some of it can be used, I guess.
No, like it's perpendicular to its old direction, but it just goes sideways, right?
Yeah, but it could be up or down. Like you don't know which way. So it's but you could assume it goes clockwise if you want for the start of this problem.
Wait. Because there's a construction for 2, right?
Right, how small do you want to start? 2?
Yeah.
Yeah.
Oh.
Yeah, I see some things. Yeah, the Taiwan thing does help a lot.
Yeah.
I feel like, let's see, if you have like 3, right? So now I'm more interested in the relationship than this problem on its own.
3 is a 4x4. Like, if we start the babies in squares instead, if we start the ladybirds in squares, it's a 4x4.
Like this.
Yeah.
That's all of them, right?
Yeah.
And they'll never meet. Is that right?
Yeah.
So what's that? So that's like odd, yeah?
Odd, there's a construction.
Wait, does that solve odd?
Yeah. That's also.
Okay, then for even... It's like... So for even there's 1, 2... How many of these are there?
That's what. Even it's 2 times the side length plus 1 extra. Is odd.
2n plus 1, right?
Yeah.
So it's like n plus 1 squared minus 2n plus 1. Alright?
Yeah.
That's just n squared.
Yeah.
But it might not be optimal. Yeah? Okay, I feel like we already had a good start. This could be good homework thing as well. Alright, I'm gonna try some small cases here. What's like a small case? 4 by 2 by 2? Did we do that already? Wait a minute. If you have like... Oh, they can't keep going along the same way. 1... Does something like this work? Let's see. No, that doesn't work, right?
Yeah.
Yeah, maybe if you can give me a proof of this case, that could be our goal for the rest of this.
Anywhere it goes, it has to pass through the center square.
Oh, interesting. So that means you could kind of start it at the center square.
Greater than 4.
It's not a bad observation. The center square.
The center square has to always be reached on the 4th move or less.
The 4th move, not the 2nd move.
Because you could do like.
Oh, you mean if you start from the edge?
Yeah. If you don't start from the center. Because you start there, you have to go 1, 2, 3, and 4.
Wait, isn't it 1, 2, 3?
No, because this will be 1. Wait, oh yeah. No, because it'll be 1, 2, 3, 4, right? So it'll be 1, 2, 3.
Wait, you're starting in the middle?
If you start here.
Yeah.
Yeah.
And it's 1, 2, 3. Right?
Oh yeah.
Okay, well that's a good point because the one in the middle has to go back to the middle very often.
Yeah.
That proves it, I think.
Yeah, that does it.
So the one that goes in the middle. Let's say we'll log someone starts in the middle, right?
Yeah.
So we'll log middle. Mid. So that means that they're gonna be back in the middle every 4, yeah?
That gives you the maximum of 4, right? Because every square has to reach the middle within 4.
So what does that mean? So for example, if something started in the corner here, right?
Yeah.
They'd have to get to middle 2, right?
Yeah.
So then something would always be in the middle every like 2 mod 4 and 0 mod 4.
Yeah. Oh wait, no, because you have everything has to come back to the middle within 3 moves. So if you leave the middle, it's back to the middle very quickly.
4 moves.
Yeah, 4 moves.
Yeah, that's why it's every multiple of 4.
Yeah.
Oh, so that automatically means if
Nice.
one person
Cool.
starts in the corner here,
Yeah.
then the other 3 corners have to be empty.
Yeah. No, but that also proves it has to be 4. Like, you
So,
can't fit more than 4 people.
well,
Yeah.
I mean, it doesn't have to be a corner. Let's see, it could be an edge. I guess the edge, right?
Still has to reach the middle within 4.
It could go in the first one, right? And then, so then it'd be like 0 mod 4 and 1 mod 4. And then when it comes back, yeah, so I guess, so if we want to be very explicit, yeah, so like, we know nothing can start in the top corners, right? Yeah?
Yeah.
And go in the middle, up to the top. So for there to be,
You can have, Michael,
what?
you have, from any position you start in,
Mm.
no matter where you go, you will reach the middle within 4 moves, right?
Yeah.
Yeah. That means the middle can only fit 4 people. Like, you can only have 4 concurrent people. Because if you have 5, and you only have every 4 they have to reach the middle, then you have one of those things they overlap.
Mm. Yeah.
Yeah. That
Sounds good. Yeah. Yeah, I guess a more explicit case back would be like this. You have 2 people out here, right? 1 person inside.
Yeah.
This person has to go to one of the corners, right? And this person has to leave. This person has... So they're going in. Yeah, because if they were both going in, this person was leaving, it would go back, both be in there at 3.
Yeah.
Yeah. And then we're in the other case where there's someone in the corner, someone in the middle. Actually, did we fully do the case with the corners? Explicitly? So your argument is that if there's 5 people and everyone has to go to the middle essentially every 4 steps, right? Some of them have to clash.
I think we've basically solved the problem with this idea.
Oh yeah.
It seems like
I would believe it if that were the case. I'll put up the next case just in case.
well, not exactly worked out the details, but like draw the things out, right? The lines.
So the middle exists.
Yeah, but no, you don't want to. It's not the middle that you deal with in that case. These 4 points.
These 4 points.
Yeah. Every 4 moves you have. At least every 4 moves you have to reach one of them from one of the points, right?
It's kind of like the... Oh, I see how you're going to generalize that.
And what you do, you select points such that they exist in every kind of... Wait, yeah.
Ooh.
Yeah, you select the middle of each of these squares.
Ooh.
Because even if you leave the square, you'll still hit another one within the next 4 moves. Right?
Yeah.
We've basically solved it. Like,
What number do we get?
because it's 4 for each. 16. Right?
Yeah.
And that's the number you get by doing the thing.
Well, what is it in general?
In general, it's the odd case.
It's the even case, yeah?
Yeah, the even case.
So
So
it's
in
like
general,
2n.
it is the amount you get when you do all the square things.
Oh, really?
Yeah, because in the 4x4 it's 4, right? Which is the amount you get for the number. In this, it's 16 because you do it's 4 because you can do this, 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 and that it generalizes like that.
Okay, so if we have 2n by 2n, right?
Yeah,
You get n squared of these dots. Is that right?
yeah,
And then you want, you get 4 for each.
yeah,
Oh, that was good. And then that's what we wanted, right? Because you want, there's 2n plus 1 spots, yeah? But there's 2n, like, that was quick.
yeah. Surprisingly, I feel like there's either two things. Either the senior problems, they just don't care about difficulty and give ridiculous problems, or combi is significantly easier.
Yeah, I mean, I definitely leveraged your brain power in this question.
Yeah.
Like, I think all I did was point to 2 cases, basically.
You
And
basically just pointed to the 2 case. Because I had, Michael, before you had written that, I had already done the 5 and the 7.
yeah, so it's pretty much all you.
It wasn't that hard.
Very good. Right, maybe I can record a summary of this.
Yeah. It's a good problem. But what's it?
You got like 2 minutes.
Yeah.
Maybe it's better with the I don't know.
Recording in progress.
Alright, so I want to give you a summary of Liam's solution to this combi problem. So first, what is the problem? It is, you have a grid, okay, and you have like a bug on these vertices in the grid, okay, and at each step, so the bugs are all at different vertices, and at each step they're allowed to move slowly in one direction at the same speed, and they get to another vertex, and when they get there, they have to change directions either perpendicular, down, or up. So here they can't go up, so it has to go down. Okay. And the question is, what's the least amount of bugs you can put on the thing so that they're guaranteed to collide at some point? Yeah?
Yeah.
Okay, so if we see Liam's solution, so the construction, basically, if you put a lot of bugs in these arrangements and just have them cycle around, okay, they'll never collide, right? So that means if there's a odd number of squares in the grid, then the least number is the maximum number as well. You can put it on every vertex, okay? But if there's an even number, okay, so for example, if it's 6 by 6, like this, okay, the answer is a little bit different, and the key idea in Liam's solution is that the bugs have to go through these red points at some point, okay, and because the red points will lead to collisions, you can't put more than Wait, it's not completely. Wait, it's kind of a little stuck here. So you can't put 4 in here, more than 4 in here because it'll.
Yeah.
So you can't have 4 that more than 4 to go into the same red dot here.
No, but it reaches another red dot within 4.
Yeah, so everything reaches with 1 red dot within 4, right?
Yeah.
And there's really only. So you can only really put. So the claim is you can only put 4 things in one of these squares, right?
Yeah.
Yeah.
No, not in one. It's just basically.
Yeah, but there's a little bit of overlap, and they could be going to the wrong one, right?
No, but overall, if you look at it,
Yeah.
because it has to go in each square, a bug goes in each square every 4.
Yeah.
In total, because you have all the bugs, if they don't overlap, there
Yeah.
will be a bug going into each different square every 4. Because if you have more than 4 bugs, more than 4 times the amount of red dot bugs, because each bug goes into one of those every 4,
Yeah.
you're going to have what's it called? Say the amount of bugs is.
Oh yeah. So I think we can clean up this argument a little bit.
Wait, denote the amount of dots by n, right? Say there are 4n bugs, 4n plus 1 bugs.
Yeah.
On each turn, there has to be at least 4n plus 1 on 4 bugs. No, there has to be, the expected amount of bugs in the things on each turn is 4n plus 1 on 4 if you have 4n plus 1, right? But because it has to be an integer amount.
I think you're abusing some of the expected and all this stuff.
But because it has to be an integer amount, there has to be
Yeah, I think it's there, but don't rush it. I mean, it's fine. Just take your time and explain it. Tell me tomorrow or something, okay? But can you see that it's not completely proved, right?
Yeah.
Yeah, because these things aren't destroying, and they might not, like the ones here might hit that one or this one, yeah. But I think the idea is strong enough to solve the problem.
Yeah, the idea will solve the problem. It's just.
Okay, let me know how it goes.
All right.
Recording stopped.
What's the how many watch hours do you reckon I got?